Let's go ahead and go over these answers that I see up on the board here. So solids, yes, are packed closely together. Yes, they tend to have less energy, both thermal, meaning they're colder, as well as less motion because they have less kinetic energy. So they don't move around quite as much, hence why they are more rigid. They don't change shape, they don't change volume. Oh wow, did it go well, Alexis? Yeah, I hope she's healing up. Liquids tend to have medium amounts of energy, so they tend to be warmer, more thermal energy, as well as they move a little bit faster because they have more kinetic energy. And with that extra space to move around, they can actually flow. Gases are the most chaotic. They have the most energy. They tend to be the hottest from their thermal energy. They tend to move the fastest from their kinetic energy. And as a result, they spread really far apart and try to escape. Awesome. I'm glad she's doing well. Yeah, hopefully that was a good way to help be supportive, to not stress her out, right? All right, make sure you're opening up your make sure you're opening up your notes there. Links are in the tab in the chat. Make sure you try both links. One will work, one won't, or you can always just go straight from your grades tab as well. Yeah, feel free to raise your hand if you have your notes open, because I'm going to ask you to do that in just a moment anyways. This is a reminder, please do not share your contact info. Please participate often and well, and make sure you are behaving appropriately. We are on day 5 out of 60 here, taking a look at classifying matter today. Remember that if you are a new student, meaning your name is down here in the yellow box, new students for trimester 3. Remember that you do need to do STAR 360 both at the start and end of the trimester. So your reading test is today at 1 p.m. Your math test is tomorrow at 1 p.m. Make sure you check your live session schedule. Again, everybody will eventually need to do this at the end of trimester 3, whether you're new or you're old. But please, for old students, do not take it until the end of the trimester. We will not count it towards your score, towards your grades, unless you do it on the right day, which is at the end of the trimester, okay? So let's take a look at our objectives. We should know the difference between mixtures and pure substances by the end of class today, and be able to provide definitions and examples of the different types of mixtures and pure substances. Please raise your hands if you have your notes open and ready to go. Raise your hands if you have your notes open and ready to go. Links are in the chat. Go, go, go. I'll give you 20 seconds to get those open. So what are the steps to make spaghetti and meatballs? Tell me in the chat. What do we do with the water? What do we often add to the water? What do we do with the dry noodles? What are the ingredients in the sauce and the meatballs? How do we cook the sauce? How do we cook the meatballs? And what is the pan often made out of? Go ahead and answer any of those questions. Tell me in the chat box, how do we make spaghetti and meatballs? Promise you this does have relevance. We'll go over exactly why we're talking about spaghetti and meatballs later at the end of class. Yeah, so we're going to boil the water, absolutely. We're going to add salt to the water, add salt, and then from there we can cook our noodles. Cook the noodles. Oh no. Yeah, what else? What else? So we have our cooked noodles, but we don't just want cooked noodles because that's super gross, right? If you're someone that only eats cooked noodles with nothing in it, that's nasty. You're a monster. Just kidding. I still love you, but you're a monster. Excellent. Yeah, so our sauce, right? That means we need something like tomatoes. Yeah, ooh, cheese, absolutely. We have basil and garlic, oregano. Yes, for our meatballs, we need some what do you call it? Mincemeat, right? Or what is that? Ground meat, ground beef, right? Absolutely. What else? Yeah, we're going to talk about what types of mixtures these are. You guys are funny. You're way ahead of it. What else might we find in our meatballs? Yeah, we need eggs and breadcrumbs. Absolutely. Definitely some cheese. What is our pan often made out of? Now, this is going to be related to what we're talking about today, which is why I'm asking you this. Obviously, the pan isn't necessarily, you don't usually need to know what it's made out of to be able to cook something. But in this instance, what is our pan made out of? Yeah, it's usually made out of some type of metal, right? So it can be made out of steel or iron or copper, right? So lots of different metals that we can use for our pans. Yeah, you don't necessarily need the eggs in the meat, but eggs are a binder, so they do help to keep the meat together a little bit more. Yeah, seasoning, perfect, excellent. All right, we're going to come back to this, so don't forget this. Hope you're getting a little bit hungry because it's almost lunchtime, so that way you have something to look forward to. So let's talk about mixtures. Mixtures are physically combined. They have 2 or more components, and because they're physically combined, that means they can also be physically separated. There are no chemical changes that are needed. So an example would be a piece of rock. You can crush the piece of rock and separate out the minerals. An example would be salt water. So salt water is just salt mixed with water. When you evaporate out the water, you still have water, which is H2O, and you still have salt, which is still chemically NaCl, sodium chloride. There's no chemical changes happening, therefore it's a physical mixture, a physical process. Smiley faces, emojis in the chat box if that makes sense. Oh yes, Tara, those things are huge. Yes. my goofball kid in the background. She just woke up. The time change is like seriously messed up her sleep schedule. Same thing with a lot of our pasta, right? The noodles can be physically separated from this spinach or basil. I'm not exactly sure what they put in here. It can be physically separated from the tomatoes. Those are all examples of mixtures. Okay, this is number 2. Fill in the blank with the word mixture. Physically. Fill in the blank with the word physically. Only the word physically. Make sure you spell it correctly. Capitalization does not matter, but spelling does. You have 20 seconds. Go, go, go. Raise your hands. Again, can it be physically separated? If yes, that makes it a mixture. Yes, we'll talk about pure substances a little bit later. Now, there are 2 types of mixtures. There are heterogeneous mixtures and homogeneous mixtures. So heterogeneous, what do you think the prefix hetero means? Do you think it means same or different? What do you think the prefix hetero means? Same or different? Excellent. I see Tara in the chat. Give me some more answers. Hetero, what does that mean? Same or different? Yeah, exactly. There we go. Yes, it means different. So when you think about a heterogeneous mixture, you should think that it looks different throughout. It is not uniform, not uniform. It looks very, very different throughout, and each sample looks a little different. This is like raisin bread. Each slice of raisin bread looks a little bit different, all right? So each slice of raisin bread looks slightly different than other slices of raisin bread. They have different cinnamon swirls. They have different amounts of raisins, all right? An example here you can see is, for example, if you take a sample from the top here, sample from the bottom here, these samples look different. One sample is mostly purple, one sample is mostly green. Awesome, Kaylee. Now, homogeneous, what does the prefix here mean? Homogeneous, homo, does that mean different or same? Tell me in the chat. Yeah, this one's going to mean same. So homogeneous mixtures look the same throughout. This just means that each sample looks the same. Tastes the same if it's something that you can eat or drink. So an example here would be sugar water. Sugar water, once it's all dissolved, if I pour it into 5 different glasses, each glass would taste and look identical. Smiley faces, emojis in the chat box if that makes sense. Smiley faces, emojis in the chat box if that makes sense. Each sample would look the same. Perfect. Example here is take a look at the top here versus the bottom here. Both of these samples are half green, half purple. They're identical to each other. Okay, this is the answer to number 3 and number 4. Please fill in the first blank with the word different, second blank with the word same for number 4. Please make sure that you spell them correctly. Capitalization does not matter, but spelling does. You have 30 seconds to raise your hands for number 3 and number 4. Go, go, go. Taking a look here, is it uniform? If yes, it looks the same throughout. That's going to be like salt water and sugar water. Each sample would be the same. That's homogeneous. If no, each sample looks different. That's heterogeneous. That's going to be like rocks or wood, for example. Wood, each slice of wood looks a little bit different. Each slice of wood's going to have different knots in it. The inside of a tree looks very different from the outside of a tree. So it is not uniform. It looks different. So that would make it like a heterogeneous mixture. All right, let's go ahead and do number 5 here. All right, which of the following are true about heterogeneous mixtures? I'm going to give you one of the answers here. Remember that mixtures, regardless of if they are hetero or homogeneous or heterogeneous, all mixtures are physical combinations. All right, they are all physical combinations, meaning that there are no chemical changes happening. They are only physically combined and they can be physically separated. Smiley faces, emojis in the chat box if that makes sense. That should help you out with this purple one right here. That should help you out with these purple statements right here. Okay, for the other two though, you can get help here. So hetero, the prefix hetero again means what? The prefix hetero here means what? Prefix hetero means, yeah, the prefix hetero means different, exactly. So again, for these other two, you just need to think about the word different, right? So if it's a heterogeneous mixture, does it look uniform, which means same throughout, or does it not look uniform throughout? Okay, based on the fact that it's a heterogeneous mixture. Don't put answers in the chat. And then the example, same thing, right? So the example down here, think about which of these, if you took different samples of this, would look different. So carrot, lettuce, tomato salad, which ones would have, if you took a bunch of samples, would those samples look different, have different amounts of carrots, lettuce, tomatoes? Same thing with black coffee. If I took different samples of black coffee, would those samples look different? Which of these has samples that would look different? All right, you should have 3 correct answers for number 5. Go ahead and answer number 5 in your notes. Do your best. This is a complete on your own. If you want to check your answers, tell me what you put in the Q&A area and I will check them for you. I will not give answers though, so you need to make sure that you are actually telling me what you put. So make sure you actually try them out on your own. Luca, if you want to check answers, I am in the Q&A chat. Go, go, go. 30 seconds. Don't put answers in the room chat. Let's go ahead and talk a little bit about pure substances. So pure substances cannot be broken down physically. The reason being they're actual chemicals. All right, so chemicals, chemical combinations here cannot be physically broken down. So an example would be elements. Elements are made up of one type of atom. So obviously you can't break them down either physically or chemically because they're only one type of atom. If you try to break them down, you still have the same type of atom, and therefore it would still be the same exact thing, okay? Now, compounds, on the other hand, I don't know what the parentheses are for. I don't know, Evangelina. What are you asking? Sorry, I'll keep looking at the chat, but I'm not exactly sure what you're asking. Compounds, on the other hand, are physically pure because they are chemically combined, so you can't physically separate them, but they can actually be separated chemically, undergoing a chemical reaction. The reason being because they're made up of different types of atoms. So examples here would be water, which is made up of hydrogens and oxygens, and hydrogen chloride, which is made up of hydrogen and chlorine. Those things can be separated chemically because they're made up of different chemicals together. Oh, from the previous slide. Oh, I'm just saying that you should have one answer per pair. One answer per pair. So one of these, it's either uniform or not uniform. It's either physically or chemically combined. And it's either salad or coffee. So you should have 3 correct answers for number 5. Okay? Cool, sorry about that. All right, elements cannot be broken down physically, that's why they're pure, but they also cannot be broken down chemically. Again, they're made up of the same type of atom. You can't get any simpler than that type of atom. So for example, helium, you try to break it down, it's still going to be helium. So there's no change if you try to break it down physically or chemically. Now, all the known elements are found on the periodic table of elements. So if you see it on the periodic table of elements, you know, aha, that is an element. They get abbreviated by either single letters like capital H for hydrogen or double letters like HE for helium. So this is something I highly, highly recommend that you actually bookmark on your computer because we will be using this a lot. This is called ptable.com. All right, so let me go ahead and show you what this looks like up here. All right, so here is the link to ptable.com right here. So highly recommend that you bookmark that. Okay, and so for example, you can see things here, right? So you can see hydrogen, helium, carbon, nitrogen, oxygen, fluorine, chlorine, potassium, calcium, magnesium, sodium, copper, silver, gold, platinum, zinc, aluminum. All of these are examples of elements that if you tried to break them down, they would still be the same exact elements. Smiley faces, emojis in the chat box if that makes sense. If it's on the periodic table of elements, it is an element. It is an element. Excellent. Yeah, I don't make you memorize these or anything, so don't panic. That's why I recommend have it bookmarked because I want you to be able to use it as a tool. I don't really ever have you memorize the periodic table. That would be too much. So don't be intimidated. All right, so this is going to be the answer to number 6. Take 20 seconds to fill in the blank with the word periodic. Only the word periodic. Make sure you spell it correctly. Capitalization does not matter, but spelling does. Go, go, go. Let's go ahead and take a look at question 7 then. Which of the following is an example of an element? Again, really highly recommend actually use ptable.com to help you. So here's the link again to ptable.com. You need to figure out which of these is on the periodic table of elements. Is it trail mix, nitrogen abbreviated as N, water abbreviated as H2O, 2 hydrogens, 1 oxygen, or green tea. Please remember, elements are made up of one type of atom, so you should only see the one that's made up of one type of atom. Go ahead and work on number 7 on your own. If you want to check your answer, I'm in the Q&A area. You have 30 seconds to work on number 7. Go, go, go. Compounds we mentioned cannot be broken down physically. They are physically pure, but they can actually be separated chemically through a chemical reaction. So compounds, again, are made up of 2 or more atoms that are bonded together, and since they're chemically bonded, they can actually be chemically broken. They can't, however, be physically broken. Think about water, H2O. I can't physically go in and start ripping off oxygens off of my water. I can't just go into my cup of water and rip off oxygens. That would actually help solve the oxygen crisis on our Earth of we're losing oxygen over time. But we can't do that, all right? We can, however, do it through a chemical reaction. So, for example, there is a chemical reaction that can be done to water through a process called electrolysis, where you add electricity to water. Don't do that at home because you could hurt yourself. All right, yeah, we could plant more trees, exactly, or stop tearing down all of our trees. It does taste planty. All right, focus, because we got to get through this. Okay, so when you do electrolysis, this causes the water to chemically decomposition into hydrogens and oxygen. So this is a chemical process, though. It is not a physical process. So that's why it's still physically pure, but it can be broken down chemically. All right, so this is going to be number 8. Go ahead and fill in the blank with the word bonded. Only the word bonded. 20 seconds. Raise your hands. Okay, so again, can it be chemically separated? No, that's an element made up of one type of atom, like gold and oxygen. Cannot be broken down into anything simpler than gold and oxygen. Compounds, yes, can be separated chemically because they're made up of more than one type of atom, like water, H2O is hydrogen and oxygen. Carbon dioxide, CO2, made up of carbon and oxygen. Let's go ahead and try this out. So let's take a look back at our spaghetti and meatballs example. Meatballs with beef, onions, garlic, herbs, and breadcrumbs. Is that a physical mixture, or do you see an abbreviation here for atoms? Tell me in the chat box, is this a physical mixture, or do you see an abbreviation here for atoms? Tell me in the chat. Yeah, this is definitely a physical mixture, right? There's no abbreviation for atoms. It's definitely physically mixed together. You physically combine the beef, onions, garlic, and herbs, and breadcrumbs. So now the next question is, therefore, if it's a mixture, what type of mixture? Homo or heterogeneous? Again, the question here is the mixture uniform or the same throughout? So meatballs, think about in the chat box, yes or no, do they look the same throughout? Think about the outside versus the inside of a meatball. Think about if you were to take different samples of the meatballs, would all those samples look identical, the same? Yes or no? Tell me in the chat. No, they would all look different. The bottom of a meatball, which is against the pan, usually gets a little bit burned. It looks different than the top of the meatball. And again, different samples of meatballs are going to have different amounts of onions, garlic, etc. So no, it's not uniform. This would therefore be a heterogeneous mixture. Smiley faces, emojis in the chat box if that makes sense. Smiley faces, emojis in the chat box if that makes sense. So this one right here is a heterogeneous mixture. Cool. All right, now sugar. Sugar, is this a physical mixture, or do you see an abbreviation for atoms? Is this a physical mixture, or do you see an abbreviation here for atoms for sugar? Yeah, we see C6H12O6. That definitely tells us that there's atoms in this. There's atoms in everything, but specifically in this is by itself one type of atoms, okay? And so therefore, all right, is this going to be a compound or an element? The question you need to ask yourself is, can it be separated chemically into different atoms? Yes or no? Are there different atoms? C6H12O6, are there different atoms? Yes or no? Yeah, there are. Carbon, hydrogen, and oxygen are 3 different types of atoms. So yes, this actually is a pure compound. Smiley faces, emojis if this one makes sense. This one right here is going to be a compound. Compound. Excellent, excellent, excellent. All right, what about salt water? Okay, salt water, is that something that's physically mixed together, salt with water, or do you see an abbreviation for atoms here? Is that a physical mixture, or do you see abbreviations for atoms? Tell me in the chat. Yeah, this is going to be a physical mixture, right? So salt literally gets physically stirred into water. All right, so that's a type of mixture. Now let's think about, Is it uniform or the same throughout? Yes or no? Think about if I take a sample of salt water, if I take 5 different samples, would they all look the same or different? Yes or no? Same, yes or no? Yeah, they would all look uniform. It looks the same. They would all look identical. So yes, this one there would therefore be a homogeneous mixture. Homo meaning same. So this one right here would be a homogeneous mixture. All right. All right, and what about iron? Iron, is that a physical mixture or do we see an abbreviation for atoms? Iron, the pan is made from iron. Do we see a physical mixture or do we see an abbreviation for atoms? Yeah, we see an abbreviation for atoms here. And so going down to step 3, therefore, can it be separated into different atoms? Yes or no? Can it be separated into different atoms? No, remember capital Fe, 2 letters count as the same atom. So Fe actually counts as the same atom, so Fe being iron. So this one is actually a pure element. So this one would be D, this one would be an element. Awesome. This is going to be the answer to number 9. So again, meatball is hetero, sugar is compound, salt water is homogeneous, and iron is an element. Go ahead and do number 9 and raise your hands. When you are done with this one, please raise your hands. You have 30 seconds. Go, go, go. All right, so these last 2 are ones that you need to do on your own, but I'm going to actually start off the first step with you. All right, so ammonia NH3, we want to figure out, is it homogeneous, heterogeneous mixture, pure compound, pure element? Do not put answers in the chat. All right, but you can tell me this. Can it be separated physically or do we see an abbreviation for atoms? Tell me in the chat box, is this a physical mixture or do we see an abbreviation for atoms? That's the only thing you can tell me in the chat right now. Ammonia, NH3, is that physical or atoms? Physical or atoms? Yeah, we can see NH3, nitrogen, 3 hydrogens. That is going to be our abbreviation for atoms. So we definitely know it's a pure substance. It is not a mixture. All right, so at this point, you should be able to identify if it's a compound or an element. Again, compounds meaning they are made up of different atoms, right? So different atoms. Element meaning it's only made up of one type of atom. Okay, so please go ahead and answer number 10 on your own. If you want to check your answer, I'm in the Q&A area. You have 20 seconds. Go, go, go. Question number 11, the jelly beans below, are they homogeneous mixture, heterogeneous mixture, pure compound, or pure element? So taking a look here, let's answer the first part together. All right, is this a physical mixture or are they, do you see an abbreviation for atoms? Is this a physical mixture or do you see an abbreviation for atoms? Yeah, perfect. This is a physical mixture, right? There's no abbreviation here for atoms, so it's definitely not a pure compound, definitely not a pure element, all right? So all we need to figure out is it homogeneous or heterogeneous? Again, homogeneous meaning it looks the same throughout. Heterogeneous meaning it looks different throughout. Think about the fact that these are made up of multiple colors here, okay? So that should help you with number 11. Go ahead and don't put answers in the chat. Go ahead and work on number 11. 20 seconds to answer that and raise your hands. 20 seconds to answer number 11 and raise your hands. Go ahead and make sure you answer number 12 right here, saying that you understand our project policy, and then you can go ahead and log on out, and I will see you all later. Bye, everyone. Thank you so much. Have a wonderful day. Go ahead and log on out.